Okay. Okay. Good afternoon, everyone. My name is Chacha, and I will be the master of ceremony for today's event. And welcome to the International Perspective webinar series. So today we will learn and discuss about the Southeast Asian Tin Belt, one of the world's most significant sources of critical metals. And with our speaker, Professor Aung Zaw Min, that coming from East Yangon University. But first of all, before we start our event today, I would like to remind all of the participants to open your camera so that we can make the event more engaging and also interactive. And also don't forget to use our virtual background that are already provided and also can be downloaded on the chat box. Okay, next. Okay, next we move to the project introduction. So let me introduce and explain a bit about our project. So the International Perspective webinar series is a series of international online.
Tata, sorry, your PPT haven't moved.
Oh, well. Okay, how about now? With the.
No, it's still in the first slide.
Oh, okay, sorry. Wait, or maybe let me stop the screen first, and I will share again. Thank you, Rivda, for reminding me. Okay, how about now?
Yes, it works now.
It works now. Okay, thank you so much, Rivda. Okay, next, we move to the. Let me introduce about our project first. So the International Perspective webinar series is a series of international online knowledge lectures jointly led by the CMO TED, China Asian Technical Education Corporations, and co-hosted by International Youth Culture and Education and Go Study. The program is expected to invite 1 to 2 school faculty members to give webinars each month, aiming to enhance and enrich the growth of knowledge and broaden the horizons of learners in the Southeast Asian region by inviting experts from different countries and fields to provide high quality and universalizable online lectures that will help learners to acquire specialized knowledge through knowledge sharing and cross cultural understanding. Okay, next. So for today's webinar event, we will have Professor Aung Zaw Min as our speaker that will accompany us and also give us new insight regarding one of the world's most significant sources of critical metals. Uh, and now, Professor Aung Zaw Min has joined us in this Zoom. Can you hear me, Professor Aung?
Yes,
Okay,
here.
okay, sir. Okay. So before we start our event, let me introduce Professor Aung. So he is a professor at East Yangon University, specializing in economic geology and geochemistry. And he also recipient of several prestigious international fellowship from Germany, China, Japan, and the United States, including awards from the Alexander von Humboldt Foundations, CAS, JESO, AUN or SEED, NET, and also SEG. And he also already published more than 19 research publications in international journals starting from 2017 until now. And his professional field is in economic geology, geochemistry, and also earth resources engineering. Okay, so now I would like to let Mr. Professor Aung to share screen and also start to share the materials. So the time and screen is yours, sir.
Okay, thank you very much for your information.
Yes, you're welcome, sir.
Yeah.
Yes, we can see the PPT, sir.
Okay. Hello, everyone. I'm Azamir from Myanmar. Today, I would like to make a presentation about the Southeast Asian Tin Belt, one of the world's most significant sources of critical metals. So, there's are 6 sections included in my talk. They are introduction, Southeast Asian Tin Belt, geological framework and metallogenic provinces, critical metal source, Southeast Asian Tin Belt, critical non-metal source, Southeast Asian Tin Belt, and finally, conclusions. So firstly, I would like to introduce you about the critical matters. Actually, critical matter is, a matter which is essential for the constructions of future clean energy devices. You all know wind turbine, geothermal turbine, solar panels, and electric vehicles. And also they are essential for the production of hydrogen for clean energy storage. Then I would like to describe what is criticality. So we we use two parameters to define the criticalities. The first is economic importance. That means that matter should be, essential for industries and technology. The another thing is supply risks. You know, supply risk is also very important factor. So here you can see that I show some critical matters. So they have risk of depletion. Some of them are okay, I mean, some of them iron, aluminum, manganese, titanium, vanadium, chromium, nickel, zinc, lead, tin, thoriums, and uraniums stay okay. That means low depletion rates. We can use them for several decades later. It's okay, no problem with them. But copper, cobalt, lithium, tungsten, antimony, gold, and silver has a moderate depletion rates. That means that we have to find more resources of them. So then high depletion rates metals are here, you can see. Gallium, molybdenum, cesium, Pg is mere platinum group elements. Then rare element, selenium, cadmium, indium, and tellurium, they have a high depletion rates. That means that we have to, care about the using of them. We need to find the new resources as soon as possible. So then I would like to introduce some significant tungsten beds of the war. They are the South Asian thin bed is today my main topics. I will focus on the South Asian thin bed. That one is done from the Malaysia and via Myanmar, Thailand to Yunnan, China. Yunnan, China is geographically not included in the South Asia, but geologically is included in the South Asia thin belt. Then South China belt, we also call Nalin Metallogenic belt. Another one is Central Andean Bolivian thin belt, then Paraguay, Angola belt of Central Africa, and finally is European Balkan belt. They are the most significant tungsten belts of the world. So, sorry. Today, my topic is about the Southeast Asia thin belt. In this slide, I describe some criticalities of the matters from the Southeast Asian thin belt. The first diagram showing the economic importance of the matters from this belt. You can see the blue line showing the EI of the 2020, and the brown represents the EI of the 2023. So it's a little bit changes. Only Indian economic importance is slightly dropping down here. And beryllium, you can see here, a little bit increase is EI. And scan diagram, we can see the supply risk values of metals. The blue lines also represent the SRR 2020, and brown lines represent the 2023. Only Indian supply risk is dropping down, you see. So we have to find the Indian resources much more in our region. So these two factors are the main factors to determine the critical metals. So key metals in primary deposits. Primary means we have to blast the mineral occurrence by the dynamites and other things, and then we can excavate them. So many metals we can find from the mineral deposits of the Southeast Asian timber. So the first thing is tin, second is tungsten, and then antimony and tantalum and rare elements, and other minor elements are also included. Tin elements is a primary metal of the Southeast Asian timber, and we produce, more than 9.6 million tons annually. You can imagine. It's maybe more than 50% of the world production. And tungsten is also economically significant, especially in southern Myanmar, northern Thailand, in Yunnan as well. And antimony is notable in the western and eastern provinces of South Asian timber. Tantalum presents in smaller quantity. Previously, it's really rich in the Thailand mineral resources, but now a little bit dropping down. We will explain them one by one later. And rare elements is hosted in the Aztec granite. Granite is a kind of magmatic rock, which is the most common rock in the Southeast Asian timber. So rare elements also hosted in the Aztec granite, especially in the western and central provinces. Then other metals are gallium, germanium, scandium, molybdenum, lithium, beryllium, hafnium, vanadium, niobium, and indium. They all are critical metals. So next session is about the South Asian timber. I will explain a little about the South Asian timber. It's a geographic scope and importance of South Asian timbers. You see, he's the Malaysia. Here, the 10 islands of Indonesia. So it extends from the 10 islands of Indonesia, Malaysia, Myanmar, Thailand, and Yunnan. So that's why I explain you that Yunnan is geographically not included in Southeast Asia, but geologically it located in the Southeast Asian timber. So it's an extensive one, around 3,000 kilometers. So regarding the critical matter production, this was supplies over half of the world's themes and important metals, such as tungsten, tantalum, niobium, reeds, indium, and antimony. Geologically, I already explained about the granitic, that most of them are magmatic rocks we call granite intrusion. They are part luminous. Part luminous means that they are very high in Al2O3 aluminum oxides. So typologically, they are S-type, N-type, and A-type granites. So they all are enriched in the critical metal. So South Asian timber provides metals essential for electronics, renewable energy, and other, many, many modern technological things. So in this figure, you can also see the South Asian timber. They are Eastern Granite Province, especially in the Thailand and the Malaysia. You can see them. They have magnetite and cassiterite. Cassiterite is a thin, a most common thin mineral, cassiterite. Magnetite is iron ore minerals. They, they are in the scan deposits and in the central, along the central province drain, you can see the S-type granites of the Palmo-Triassic age. Their age is very old, maybe around older than the 200 million years ago. And they associated with the thin tungsten mineralizations and rare elements. Along the Western Granite Province is mostly ran through the Myanmar and some parts of Thailand, and east continues to the Yunnan. So along the Western Granite Province, you can see the S-type granite. S-type granite is associated with the tandem mineralization, niobium, tantalum, lithium, fluorine, and antimony. And N-type granite with the gold mineralizations and also copper. So on the westernmost margin, you can see another granite belt, window pupa egg here. So most of the granites are N-type and they are associated with base metal, mainly copper, and gold mineralization. It's a brief geology of South Asian thin belt. Maybe all of you are not geologists, I think, but I like to explain briefly about the geological settings of this belt. Mhm. Okay, then I'd like to continue about the geological framework and metallogenic provinces. Genetics. Genetics, I wish to explain how the thin bearing granites are found. Mostly they are crustal dry granite. Crabs is a upper layer of the earth. We all are living on the earth. So you can divide three parts. The innermost part is we call core, and then the middle part is mantle, and uppermost part is the cracks. So most of the granites in the South Asian thin belt are, derived from the cracks, melting off the cracks, and then these granites are found. So they are, found from the sedimentary crustal melting, and it's control the mineralizations to concentrate the volatiles. Volatiles is the like hot water and some gaseous metals, and including the incompatible elements. Then they trigger the magmatic fractionation. Magmatic fractionations and concentrate the hydrothermal fluids. And finally, they are cooling down as the mineral deposits. That's why we can see many tungsten mineralization, tungsten deposits along the South Asian timbal. Regarding the deposit types, we can classify 5 types along the South Asian timbal. The first thing is a quartz veins. Quartz. Most of mostly quartz. You all know is quartz, I think. So because if you are using the glass, that is made out of quartz. So that's why quartz vein is like that. Quartz vein also carry 10 downstream minerals with polymetallic sulfides, and then chrysan. Chrysan is a kind of rock. It holds cassiterite and wolframite. Cassiterite is tin ore minerals, and wolframite and tungsten ore minerals. Then pegmatites. Pegmatites also very important. They host cassiterite, wolframite, not only tin and tungsten. They also host the tantalum, niobium, lithium, and many critical metals. And then scan found through the fluid carbonate interactions and placer. Placers is like weather deposits. They concentrate many heavy minerals. I will show the figures of them in later. So, hydrothermal quartz cassiterite veins, we can see the tin in quartz vein associated with wolframite and sulfide. And glycosyl veins, the same, or the granitic zone rich in quartz and muscovite, they are glycogen. They host tin and tungsten mineralization. And then pegmatites, very coarse grain. Coarse grain means very big. Their crystals are very big in the rocks, and they host tantalum, niobium minerals. The mineral names are columbites, tantalites. And then scams found by the reaction of mineralizing fluids with carbonate rocks. They contain cassiterite, scheelite. Scheelite is the tungsten carbonate minerals, and then base metal sulfides. And final ones is placer. Placer is product of weathering, like a swine and other things and metals, deposited in a lake like this, and together we call placer. So many South Asian countries have the primary deposits or tungsten minerals. In our country, Myanmar, we call Western Province, they have many tungsten deposits. Example, Mochi, Bidachang, Dawen, Ye. In Malaysia, Main-Ridge Granite, it holds hydrothermal veins and glycine zone. In Thailand, Northern Province, they have scheelite-rich camps. And Indonesia, limited low deposits, mostly placer and pegmatites, especially they all are located in the 10 islands. And Yunnan is a northern continuation of Western Province, example, Lidishan deposits. So yeah, you see, I want to show some figures of the tungsten mineral deposit type. Quartz vein, you can see they are quartz vein. The rock is granitic, you see, and here it holds the many quartz vein. This quartz vein contains the critical metals. So it's a glycine. You can see the glycine. Glycine means quartz and muscovite. Here, many flakes of muscovite and quartz. The dark layers contain the ore minerals, especially critical metals, tin, tungsten, molybdenum. So it holds by the metal sedimentary rock. Here you can see very clear the molybdenite. Molybdenite is a kind of sulfide minerals containing the molybdenum here. Another one is scan. Scan is like a very big body. It's from our country, they are the normal sediments, and it's a scan zone. So if you crash dams, you can see the many old minerals in the scan bodies. We uh, extract many tin, tungstens, and fluorine from these scan rocks. So this is the pegmatite. Pegmatite is a very big, like a dike, but unfortunately it's the weather. Weather is a friable like swine, so we call in geology weather. So whether pegmatite dies, many weather pegmatite dies, they operated to produce some tin, tungstens, and lithium from weather pegmatite here. So they are also weather deposits, some quartz vein, small quartz vein. Here is the even granite body contains the 8% tin. You can see it. 8% tins are very high grade. So here weather rock body, but we can find the tin tungsten metals in the weather granite body. So it's a placer. Placer is like a swine-like deposit. You can see they are swine, but they are not like the ordinary swine because you can get the cassiterized from this kind of swines. It's from the southern Myanmar. We have many tin placer deposits like that. Okay, I will continue to explain about the critical matters of the Southeast Asian thin belt. So the most common critical metals of Southeast Asian thin belts are tin, tungsten, tantalum, antimonies, and rare elements. So tins, we we can get tin as a cassiterized in the vein. Load means a veins. I already show you the quartz vein and the placer. You can see them. And we can see them in all provinces, especially Malaysia, Indonesia, Myanmar, and Yunnan. So their resource is very significant, greater than 9.6 million tons. That means greater than 50% ore output every year. And tungsten wolframite in hydrothermal veins. Wolframite is, tungsten, iron, manganese oxide mineral. So especially in Myanmar, northern Thailand, and Malaysia, they can produce the tungsten, but it's associated with the cassiterite. We call it a major byproduct. Byproduct means a minor mineral. And tantalum. Tantalums are tantalums from the pegmatite granites. They are also byproducts, especially from Myanmar, Malaysia, and Thailand also. Previously, Thailand is a major tantalum producer. But compared to tin and tungsten, it's very minor byproduct. And antimony is antimony occur as sulfide veins and scams in northern Thailand and East Province and Myanmar. So their mineralization style is a little bit different from the tin tungsten mineralization. And rare elements is especially from the granite and placer. So their locality is not from everyone's localities. So anyway, we have potential future resources, many potential future resources in South Asian timber for rare element production. So we will start to discover the tin producer of the world. Here you can see many countries produce tin producer around 2010, Thailand, Indonesia. But then around 2023, Indonesia is still major producer, and some parts of the China is also from South Asian timber and Myanmar. So you can imagine. So world productions are mainly controlled by the South Asian timber and China. The outcomes is I explained, as I explained, is we can see as a cassiterized in primary quartz vein, hydrothermal veins, chrysostom zones, and secondary soil-rich fraser deposits. And they often associated with wolframites and sulfides. Why they are critical? As you know, they are very high in our region. So Central Province, Main Range, and Northern Province, Malaysia, Thailand, Myanmar, Indonesia, Tin Island, and Western Province, Myanmar, and Yunnan. You can see. So why we call this the criticals? We can use tin in the electronics and electrical, like circuit boards, semiconductors, connectors. They all need tin. And platings and coatings. We know platings and coatings. If you like Coca-Colas and other famous beverage. So platings and coatings, and then alloy. They are also alloy. As so we all know bronze. So bronze are tins and coppers alloy. And then chemicals. Tin compounds in PVC stabilizers. And catalyst. We can use tin as a catalyst in plastics and glass manufacturing. That's why tin is critical. So I will continue about the tungsten. Frankly speaking, tungstens are in our region, only China, great. But, as I explained before, Myanmar also have many tungsten deposits, but they can't produce very well. Tin is more popular in our region. But here, Vietnam is Asia country, South Asian country, but it's not included in the South Asian timber. But China, some parts of China are included in the South Asian timber. That's why I want to show this diagram to you. Tungsten is, mainly associated with tin in the hydrothermal quartz vein. Tungsten here you can see wolframite composition. The iron, manganese, tungsten oxide. So that we call it wolframite. We can extract the tungsten from this mineral. It's associated with cassiterite. You can find this in Myanmar, Thailand, and Yunnan. And chrysostom veins and scan, but it scans another tungsten mineral, scheelite. You see, capsian, tungsten, capsium tungsten. we can call it chemically. But we call it scheelite. Its mineral name is scheelite. So it's mostly common in the carbonate hosted system of Myanmar, Thailand. And then placed deposits. Myanmar doesn't have any placed deposits or tungsten, but it's very common in the Malaysia, Thailand, and China. So Myanmar, we can see the wolframite and scheelite deposits. So they are hosted by the 85 to 60 MA means a million years. It's very old. Very old Cretaceous to Paleocene deposits. Also types of hydrothermal veins, chrysoms, and scan. On the northern Thailand, you can see the wolframite in the 79 to 49 million years old granites. And hydrothermal veins and scan carries them. In Malaysia, wolframite is a very common tungsten mineral. They are hosted by the Permian, Late Triassic, and Cretaceous granites. They all are in quartz vein. So how about tungsten? We can use them. That's why they are critical. We can use them for the electronics. High temperature application, they are essential for aerospace turbine blades and rocket engine nozzle and helmet tooling, smelted carbides. Tungsten carbide is very famous. You all know it, I think, tungsten carbide. So for cutting tools, drills, and mining equipment, we use tungsten. And then filaments for lamps is the tungsten filaments. And electrical contacts and semiconductor, tungsten is essential. And then wear assistant coatings and radiation shielding, tungsten also critical. That's why the tungsten is a critical metal. So it's antimony. Antimony is like that. Mostly the Thailand is the major antimony producer around 2010, but now it's mostly occupied by the China. So China antimony production is very, very high. 96% of the world. But some parts of China's included in the South Asian timber. That's why we show you these diagrams. So regarding the antimony in Myanmar, there's very significant tendence deposits and eastern part of the country like Shan, Kayin, Kayah states and Sky region. And Thailand and Laos, small scale antimony occurrences linked to 10 tungsten bars. And Indonesia, some antimony traces in polymetallic tailings. So for primary sources, hydrothermal quartz stibnite is a tungsten sulfide minerals based in orogenic mountain ranges. So, and then 10 tungsten granites and shear zone, we can see the antimony deposits. For secondary, primary is it found beneath the surface, especially in the part of the earth. Secondary means the deposits found in the surface, at the surface of the earth. So we can see the tailings from polymetallic tungsten minings. The key minerals of antimonies are stibnite and tetrahedrite. But most common is stibnite, not tetrahedrite. So we can use antimony in many industrial purposes. One is a flame retardants, that's the textiles and electronics and batteries. It's like alloying agent in lead acid batteries. Another alloys is bearing, sodas, and cable sheetings, antimony is essential. And then regarding electronics, antimony can be used in the semiconductors and pigments and chemicals of antimony is an essential element. For tantalums, you can see Thailand is a major tantalum producer around 2010s, but its production is significantly decreased because Rwanda and Congo, many African countries, find many tantalum resources, and their production rates are extremely high, and now they are the major tantalum producers of the world. Even Brazil production is, you see, around 2010 is more than 50%. So they produce now just 90%. So that means that African tantalum poses giant. So anyways, we can get tantalums from the South Asian timbers on the Peninsula Malaysia. They are hosted by the highly fractionated granites, waterfall granites, and pegmatites. They are enrichments in Mudritsky. The main ore minerals are columbite, tantalums, and microlites. In Myanmar and Thailand, tantalums, tantalum is very common in thin granites and pegmatites, but their contents are very low, mostly low. That's why their production is not significant in our region. The minerals as columbites and tantalums. And South China, Yunnan, and other, all are, located in these South Asian timber. We can find tantalums in the scams and granite, but their grades is a little bit low, generally low, and associated with cassitarites. So tantalum sources as SCD. SCD means lithium, cesium, and tantalum-rich pegmatites and highly fractionated granite. But in some dense metal slag, we all have dense metals in the South Asian regions. So sometimes they dispose the slags. So, but in the slags, we found 3 to 10% T2O5. So that means that we can produce tantalums from the dense metal slags. And key minerals are columbites and tantalites, microlites, and pyroclasts. The most common are columbites and tantalite. So tantalums are, tantalum production is also very important for the modern technologies. We can use tantalums in the electronic, superalloys, medicals, and other fields. Electronics, tantalums is essential components of the capacitors for the smartphones. And you see, everybody has a smartphone. That's why tantalum is critical. And computers, automotive, and electronics. A superalloys is also, critical for jet engines, turbines, and aerospace components. Medical is surgical implants and instruments also contains tantalums. And other optical lenses and high-performance glass. High-performance glass, that means fiberglass, and then optic fiber, so for internet, we always use the optic fiber. Optic fiber is a kind of high-performance glass. It contains tantalum. So rare elements is everybody knows rare elements, the most important critical metals of the world because it's essential for the green energy. EV motors, wind turbines, and batteries, and electronics is a permanent magnet, display sensor. So arrays are critical for our knowledge age. So we can classify two types of RE. One is LREs and another one is HRE. LREs mean the light. H is a heavy. RE is a little bit lighter. Whereas element groups and heavy is their atomic mass is a little bit heavier than the light group. So dysprosium, terbiums, and yttriums. So around 2010, RE producers of the world are United States, India, and China, but it changed. Around 2023, Myanmar. Myanmar became the major producers of the rare elements. So most of the rare elements resources are located in the South Asian thin belt. It produced, and in some parts of China, the same. They are from the South Asian thin belt. So what are the rare elements bearing minerals? You can see that the first one is phosphate mineral, monazite, xenotine, apatite. Carbonate mineral, pyrrhotite, allanite, bastnasite, and other, telluride and zircon. They all contain rare elements. So mostly they occurs in the primary deposits, means granite. I already show you the granites and quartz vein. They contains the rare element. And secondary deposits in the weather granite. I show you some weather granite photos. So weather granites tailing is a disposal of the mines. We dispose the many waste from the mine sites. We call it tailing. And the alluvium flazer. So they are secondary deposits of the rare element. So in South Asian thin belt, rare elements occur Myanmar, Indonesia, Thailand, but mostly in Myanmar. It's very significant. Major suppliers of the heavy rare elements. By the way, heavy rare element is, price is much higher than the LREs. So that's why Myanmar is the major suppliers of HREs to China, especially dysprosiums and yttriums. So 75.6% in 2021. And Indonesia and Bangka Islands, you can see RE-rich tailing, and Thailand and Malaysia also has some REs in the granites, plazas, and tailings. So, but the challenge is sometimes their existence is a little bit complicated. They have radioactive elements in the rare element mineral. That means that it's very complicated for mineral processing. It's a problem. So as I explained, rare elements are critical for green technology, and for energy saving, energy efficient libels, and wind power turbines, clean alternative to hydrocarbon fuels. As you know, wind power turbines, not only wind power turbines, they are also essential for the solar panels. So now, so RE uses very significant. Every magnet contains the neodymiums and praseodymiums. They are rare elements. Dysprosium for wind turbines and EV motors. So such kinds of magnets, special types of magnets contains these REs. And phosphor, fluorescent lamps and display screens. They also contain the rare elements. And then catalysts, automotive catalyst converter, and optics and laser. They also contain the rare elements. Otherwise, their performance will be poor. That's why high performance glass, fiber, optics, and laser system contains the rare elements. So another element is lithium. Everybody know lithium because we frequently use the lithium battery, right? So that's why the lithium is also critical. So in the South Asian thin belt, lithium is hosted in the lithium, cesium, tantalum pegmatites. So a special type of pegmatites is contain these three metals linked to the S-type granites. So primary lithium minerals are lepidolite, is a mica, it's a flaky, materials and spodumens and phytolite. So associated byproducts are tantalum, rubidium, and cesium. So currently, I think exploration hotspots for lithiums is Thailand. Round lithium projects. It has a little bit, 40.8 million tons. That means a little bit high, all grades deposits. Then potential resources are Myanmar. So Myanmar also has many SCD pegmatized valleys, but we focus only on the tin production. So in the futures, I think they will focus on the lithium production. So we can use lithiums in the energy storage system. So rechargeable battery that we all know, they are lithium battery, lithium cells, electric vehicle batteries, and glasses and ceramics also needs lithium. So you can see the cupware, glass panel, ceramic tiles, and aluminum lithium alloy is, is a really great alloy for the aerospace application. So lithium is critical. And air and gas treatments, so many medical materials needs lithium. So another element is molybdenum. Molybdenum is also found as a molybdenite in hydrothermal microspace applied dyes. They are associated with the tungsten system. In Myanmar, molybdenite is very common in the late stage. Quite space in the Toy and Eight in Thailand and Malaysia. Molybdenite is hosted by the granite beds and scam zone. In St. Helens, we can see molybdenum. So we can use molybdenum as a steels and lines, high strength, low lines. We are SSLE steel, and aerospace and power generation. And for chemical applications, lithium can be used as a catalyst for petroleum refining. Petroleum refining is also very important process, and pigments and corrosion if it does. And in industrial, lithium can be used in the furnace electrode and heating elements and reading X-ray anodes. Sorry, molybdenum, not lithium, sorry. And regarding electronics, molybdenum can be used as heat sinks or the semiconductors and thin film coatings for LCD display. Okay, they are critical metals we found in the South Asian thin belt. And this table also shows some critical metals, but they are very small amounts. Scandiums, in South Asia country, Philippines is a very good, has many scandium resources, but Philippines is not included in the South Asian thin belt, only Thailand, Malaysia are in the belt. Indian is a minor processing, and they can and primary production dominated by China and South Korea and China, but we can find some Indian resources in Thailand. That's why we describe here. Regarding the gallium and germanium, Malaysia deposits contains the galliums and germanium, but and they don't have they can be produced from the Malaysia so far, but in the future we are not sure. And beryllium, hafnium, vanadium, niobium, not significant in our country. Myanmar has some beryllium deposits, but they don't have beryllium production. Okay, so I would like to follow another sessions is critical non-metals or South Asian Tibet. But actually, my topic is about the critical matters. But from the South Asian Tibet, we can also produce the critical non-metals. They are also critical for the industry. That's why I want to describe only two non-metals from this part. One is the silica. We all know silica. Silica is a very, supply rate is very low. That's why the silica is also critical. And especially high purity silica is a strategist and critical, essential. Because as you know, every electronic devices have semiconductors and photonic cell. So they are mainly made up with silica. That's why the silica is always critical. And silicon is listed as the critical material in the EU, United States, and Canada. So for renewable energy and other electronics, that's why I put silica in here. So economic potential is we can produce easily quartz from the pegmatites. So, and historic tin mines, because tin mine is only focused on the tin, but I already showed you that quartz base and other quartz. So silica is the major components of quartz. So if you have a quartz base and other things, so previously they don't have any values, commercial values, but now they are also very significant and critical for the technology. So silica glass manufacturing is very, you know, container glass and other glass than optics. Every glasswares are made by the silica, and construction and foundry stamps and hydraulic fracturing and electronics and solar and others. Everything has a silica. And another matter is fluorine. Fluorine also classified as a critical material, mineral resources like fluorides and topaz and chrysosomes, and they are also associated with the grasping chrysomes and scams of our country. So where we can use fluorine and the chemical and industrial application, we can use as a fluoropolymers and refrigeration and cooling. So fluorine is very common, when you wake up in the morning, you will use the toothpaste and toothbrush. So most of the toothpaste are, included fluorine, fluorine rich toothpaste, very nice. I like fluorine toothpaste. So, and then energy and nuclear has a fluoride, is critical. And electronics and semiconductors, they also contain the fluorine as a hydrofluoric acid. So that's why fluorine is also critical. So it's a brief conclusion, very short conclusions of my presentation. So South Asian Timbers is the most important tin producing regions in the world, So contributing between 40 and 45, but previously, at the moment, maybe I think greater than 50% of the world's total historical tin mine production, current production, greater than 50%, I think. And then we have quaternary. Quaternary means very young places, poses sometimes onshore and offshore major sources of things, especially in the Indonesia and Malaysia. And downstream also occurs alongside thin in the western part of the bed and rare elements. We found rare elements along the western part of the bed. Now, very famous for the RE protection. Yes, and copper, lead, zinc, and ammonia also present in the specific metallogenic provinces within the South Asian thin belt. So you can see that's why the South Asian thin belt is a vital source of many critical metals for electronic industry and the green energy technology. So there are some references are used for this presentation. Anyway, thank you very much.
Okay, thank you very much, sir, for the insightful presentations. I think your explanation has given us a clear understanding of how the Southeast Asian Tin Belt plays a crucial role in global critical metal supply. And I personally gained many insight about the critical metal source, and I found the topic is very fascinating, especially knowing how essential these metals are for global industries and also modern technologies. Okay, so I think next we move on to the Q&A sessions. So if anyone has questions, feel free to raise your hands if you want to ask directly to Professor Aung, or you can also write your questions in the chat box. Okay, since I saw that there are some people that already asked their questions in the chat box, so I will try to read it, and then maybe Prof Aung can answer the questions. Okay, wait. Okay, so for the first question, sir, uh, there's a questions for Butoy Ching Marma from Bangladesh. He asked about I would like to know how this webinar is important for an electrical and electronic engineering student because he can relate some materials that is included in his electrical material course. Maybe you can answer the questions and answer. Sorry, sir, you still mute, I guess. Sorry, sir, it's still.
Yeah.
Okay.
I also searching his question in the message.
Oh, you already answered the questions?
Yeah, because it's a little bit long, so that's why I want to check which parts are included in the questions. I had which minerals are important for the electronics, right?
Yes, sir.
Right? Yeah. Yeah, because for electronic device, most of the critical metals are essential. That's why so when I was Japan, I visited to the optic fiber, optic fiber. So optic fiber is a essential one, optic fiber industry. So we know that optic fiber is mainly, composed of the silica, critical nanometer. But to make a better quality of the fiber, we need tantalums and rare elements. That's why they are also very important. Although they are not the major components of the fiber, but they are very important and critical to make the other fibers. And then for electronic devices, especially rare elements and tantalums, they are very important, I think.
Okay, so much. Thank you so much, sir, for the answer. I hope it's answering your question.
Now, okay.
Yeah, for
As a
Mohan.
DV, okay.
Yep.
As a DV supplies more than half of the world's stems and several other critical metals. In your view, what makes this region so protected compared to other tin producing areas globally? It's a great question. Thank you. Okay. So productive means now I explain about the mineral resources of the tendon bed. But to produce them more effectively, we need the technology, technology like ore processing technology, mining technology. It should be the advance. That's why we need many human resources. You know, they are most important factor. Uh, I mean, we need many good geologists, many good processing mineralogists, good mine geologists, good mine engineer. So if we have then, we can compare to the other tin production area globally, I think.
Okay, sir.
Mhm.
Okay, so the first one is also the technology. It should be advanced first, yes, sir. So to make
Yes, 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 yes.
productive.
Because the problem is last time I saw, for example, we have 50% of tin in the sample, but we cannot extract all. You know what I mean?
Yeah, yeah.
Because of the technology, sometimes we have only 30%. So that means that 20% is in the waste.
Mm,
It's like a example. That's why we need the technology to extract the metal, everything, sig-
mm,
uh, efficiently from the uh, ore production. It's very important, I think. Yeah.
okay, sir. Yeah. But the
Mhm.
good thing is the SETB have the right technology to make the products
Yeah,
become
yeah, 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 you're
more.
right.
Okay, maybe next question, sir. From Faiza,
Mhm.
she asked about the key metals listed in the Southeast Asian tin belt. So, which of these metals currently plays the most critical role in global industries and why?
Which matters?
Yep, which metals?
Tin, tin and rare elements. Yeah.
Tin and tungsten.
Rare elements is the most critical role in global industry now. So that's why I told you is that without rare elements, you cannot use smartphones. It's very critical.
Okay.
Every
Yeah.
smartphones, every electronic device, if you have like EV, even EV and solar panels, wind turbines, everything needs rare elements. That's why rare elements is the most critical role.
The most critical. Okay.
Yeah.
Okay, so that's the answer. Yeah, for that. The earth elements, because if we don't have the earth elements, then we cannot provide the smartphone that you use currently. Okay. Okay. Next questions. From Rais Yahya.
Mhm.
So he asked about Indonesia is known more for placer deposits than primary lode deposits. Could you explain why primary lodes are limited here
Hmm.
from Indonesia?
Yes, I saw his question. So because uh Indonesia is also, located in the South Asian Limbat, but only 10 islands, 10
Yeah.
islands are very famous for the tin production. That's why they have only preserved poses because uh, it's depends on the geology, geology,
Oh, I see.
because
Yeah.
or geological evolution. It depends on the geological evolution. That's why they don't have primary
Lot.
tandem in the poses.
Ah,
But the Indonesia have a lot of gold,
yep.
gold
Yeah.
deposits,
We have
other
got here.
mineral resources. So it depends on the geological setting.
Hmm.
Yeah.
Okay, so the answer is because I think it depends on the geology, sir, as you said
Yes,
before.
yes.
Yeah. Okay.
Because of geological setting. Yeah.
Yeah. Okay. Maybe next questions from Mustafa. So he asked about what are the contributions and challenge of mining industry in Myanmar, and is there any initiative by the Myanmar government to strengthening this industry to contribute the Myanmar economic growth and the Asian region? I
Yeah,
think
yeah.
you have
It's
the question.
sure because sure. So uh every I think every developing country has challenges for mining industry, I think. not only in our country. But last time, maybe 2 or 3 years ago, uh, our government's trying to, you know, uh, produce the mining law. Mining law is essential for the mining industry.
Okay.
So, yeah, every country should have the mining law. So it's praying above their explorations, mining and production regulations, officially.
Yep.
So we need that one. So we are still, preparing the mining law. So after we finish the mining laws, maybe our mining industry must become better, I think. Yeah. So if we have a mining law,
Mining law.
our economic growth will be much bigger
Oh,
and bigger. Yeah.
so actually, the main challenge is in economics, right? Like because of the mining law
Mhm.
is not like
Yes,
decided yet.
because yeah, it's essential, I think.
Ah, okay.
Mhm.
Okay, thank you so much, sir. Okay, maybe the next questions from Adele. So she have two questions. The first question is, I'm curious on how does large-scale tin and tungsten mining, especially in the Southeast Asian tin belt, affect local systems, especially
Mhm.
in Myanmar, Thailand, and Indonesia. And also, the second question is about many mining areas overlap with indigenous or rural communities. So, what are the main social environmental challenge faced by these populations?
Yes,
Okay.
it's essential. That's why now well, what is populous, green mining.
Mm,
In mining industry, they also use the green mining. Green mining, the term is become popular. That means we need to explore and produce the mineral resources, without environmental impacts. It's very important. That's why we need to care the environmental system. I think Adele is also worried about that. I think because Myanmar, Thailand, Indonesia, all are the developing countries. That's
okay.
that's that's why that's why sometimes the mineral explorations or mineral industry can affect the environmental system of the mining area. It's true. But now in our country, before you produce the you before you operate or produce the mineral resources, you
Mhm,
have to report, you know, report including the environmental considerations to the Ministry of Mine.
mhm,
And so then the Ministry of Mines will examine your reports. If your proposal is perfect, they will allow you to operate that area. So environmental concerns is very important. But I'm not sure about the Thailand and Indonesia.
mm.
So
Yeah, it's
yeah,
like Myanmar and
yeah.
Thailand. Yeah, yeah, it's also to prevent the problem with the rural communities, yes, sir. So we have to report. Okay. Next question is from Shafira. So the question is from the deposit type slide, which one plays the biggest role in tin and tungsten productions in the region, and what is the reason of it?
Uh, yes, for deposit types, quartz veins are the most common deposit type. But actually, scams is also very, important deposit type. But we don't have such kinds of deposits. So
Mm,
that's why it's in our region, quartz veins and pegmatites are the most common deposit types, and they play the biggest roles in intestine protection in
okay.
our region, I think.
Ah, okay. Okay, thank you so much, sir, for the answer. Okay, maybe next question is from Rifda. The question is, since supply risk partly depends on governance indicators. How do political and regulatory factors in Southeast Asian countries affect environmental protection in mining areas?
Yes, that one is quite similar to my previous answer. Yeah,
I think it's the
environmental
same strategy.
protection is essential. Every uh mineral production company, you know, master the environmental impacts of the region. That's why they have to prepare the environment concerns in their proposal
Mm,
for mining, essentially. I think every countries have such kind of rules, you know. So if a mining company want to operate the region, so they have to submit a proposal to the Ministry of Mines. In
yeah,
the report, they have to explain which kind of factors they will they have to prepare for the environmental concerns of the country.
I see.
Yeah.
Okay, thank you so much, sir. Okay, maybe next questions is from Rifda. Uh, in your slides, you mentioned that recycling contributions or EOLRER in supply risk. How can Southeast Asian countries uh,
Hmm.
recycling infrastructure to reduce dependency on primary mining? I
Yes.
think that's kind of
It's also a good question because uh but um it's a little far from our region, because in the developed country like EU or United States now they are focusing on the recycling process. I
oh,
mean, for example, lithium battery, we dispose the lithium batteries in the garbage dams. But now they are focusing how to extract the lithium from the old batteries, you know. So
okay.
like that, they are trying to recycle. So, but hmm, it's depending on the money.
Yeah, depending on the money. Because money also leads to
So,
the technology. So,
yeah, at the
yeah.
current stage, it's a
Yep.
little bit difficult to reduce the dependency on the primary mining.
Mm.
I think so.
Yeah, yeah. Money does talk, yes, sir.
Yeah, you're right. You're right.
Okay, maybe next question is from Lilith. Okay, she have two questions. The first question is, are there sustainable or community-friendly mining practices being implemented in Southeast Asia? And the second one is, how does research on tin and associated critical metals contribute to regional industrial development?
Yes. So regarding the first question, for sustainable or community-friendly mining practice is very important. We all know it. But sometimes it's, relying not only on the uh, governments, but
Mm,
also on the mining companies, you know. That
mm,
means which kind of mining companies are operating in your country is very important, you know.
yes.
Sometimes they say they will focus on the environmental impacts, blah blahs, but you know uh, some they don't care. Actually, they don't care. It's very important. That's why community-friendly mining practices are very important. We all know it, but some of companies don't care. So how can I explain it?
Yeah, I get it.
So yeah, it's a little bit difficult, tough
Difficult and
to
complicated, yeah.
answer.
Mm,
Yeah. And tin and associated critical mineral, the second question. Tin and associated critical mineral contribute to region industrial development. Sure. Because tins and critical metals are, essential for the industry. We all know it. So
yep.
we have such kinds of metals in our region. So we have to use it. We have to utilize it. You know, that's why that we need human resource, Otherwise, we cannot use them.
Mm-hmm.
You know,
Yep. That's right.
yeah. That's why. So how does research is always essential. So which kind of research you want to do? So I'm also, stay focusing on the data associated critical mineral resources from our geological perspectives. You
Mm.
know,
Yeah.
that's sometimes uh, not sometime. I always trying to search the new mineral resources, new mineral deposits in our country is our duty, is my responsibility. So, and other scientists are also have a responsibility to do the research from own perspective to, to grow our mineral industry and other industrial development in our South Asia region. I think so.
Okay. Okay. Thank you so much for the answer. Okay, I think we still have like 4 minutes. If you have any questions, you can just put your questions in the chat box or ask directly to Mr. Prof. Oh, oh, maybe, sir. I personally have a questions. Okay,
Hmm.
okay, about the on your conclusion. So I say that the belt contains many critical metals like tin, and then tungsten, grease, and other essentials for electronics and green energy technologies. So, how do you see the Southeast Asian tin belt contributing to the future global technological development? Maybe for like next 5 years or like next 10 years. Yeah, just kind of curious about that, sir.
Hmm. Uh, hmm. Maybe we still need that. Maybe I think we still need 15 or 20 years to, yes, more than 10 years, I think.
More than 10 years.
10 years because we need some stability, like, I mean, social stabilities, political stabilities, many other things that we need to check.
So I think depending on uh the development of the critical metals itself, yes, sir.
Yes, you're right. Yeah.
Okay. Okay. Since there are no questions anymore, I think the time is almost over. Okay, so I think we can move to the next sessions, which is the group photo sessions. And thank you so much, sir, for the answer. It's such an insightful presentations. Okay, next, um,
Right. Go
we
for
move
the-
to the group photo. Okay, so to all participants, I hope you guys can open your camera and also don't forget to use our virtual background that already provided uh, by the grocery comment. Okay, I think I will wait for about 30 seconds. I hope it's enough. So everyone to open your camera. And I think after this group photo session, my college will send the attendance link for the get the certificates. So you can currently wait for the group photo session first. Okay, maybe another 10 seconds. Let's wait the other to open their camera so that we can have a group photo sessions. Okay, maybe I will start to take the screenshots. Wait. Okay. Okay, so for the first slide, I will count from one. 1, 2, 3. Okay. Good. For the second slide. 1, 2, 3. And then next for the last slide. 1, 2, 3. Okay, once again, thank you so much to our speaker, Professor Aung Zaumin, and also all participants for joining today's international webinar. We hope the insights shared about the Southeast Asian Tin Belt and its global significance have been valuable and enriching. So, but before I close the event, do you have anything to say, sir, for the participant?
Yeah. Thank you very much, everybody. Yeah.
Okay, thank you so much, sir. We appreciate your time and also participations, and we look forward to seeing you in our next event. Have a wonderful, guys. Thank you so much, sir. Thank you so much, everyone.